Trigonometric identities will be used throughout this class and throughout the calculus sequence. But as far as this particular section goes, this is what we're going to do with the identities. There are two types of problems we're going to review. You should have done similar things in your trig class. So the first thing we will do in this section is discuss how to find the values of the trigonometric functions of theta when the value of one function is known and the quadrant of theta is also known. And then the other thing we will do later in this section is take a trigonometric expression and use the fundamental identities in algebra to convert it to an equivalent trigonometric expression. Okay, so that is coming up a little later. Okay, so let's start with our first type of problem on page 2. Okay, so we are going to review how to do this. Let me jump to page 3 to kind of jog your memory of the type of problem I'm talking about. So if you go to page 3 in example 1, you'll be asked to find the remaining 5 trigonometric functions of theta if you know that the cosecant of theta is equal to -5/2 and the angle theta is in quadrant 3. Okay, so you can see what's going on here. You're given the value of one of the 6 trigonometric functions, and you're told the angle in which the quadrant in which the angle resides, and based off of that information, you have to come up with the remaining trigonometric functions of theta. Okay, so that's the kind of problem I'm talking about. Let's review how to do this. Okay, so it says, given the value of one trigonometric function and the quadrant in which theta lies, the exact value of each of the remaining 5 trigonometric functions can be found in either of 2 ways. And as I go through these methods, okay, I don't care which one you use. You pick the method you like the best. Okay, the first thing you can do, method 1, you can use identities. So you can use the appropriate identities to find the value of each remaining trigonometric function. Okay, so the other thing you can do, okay, I guess one of the drawbacks of method 1 is it's not visual. Okay, you're just plugging and chugging into identities. Method 2 is more of a visual process. So if you're a visual learner, this might be good for you. You can draw a right triangle in the appropriate quadrant. Okay, and there's a few steps associated with this. So in step 1, the first thing you would do is draw the angle in standard position by having the initial side of the angle lie along the positive x-axis and the terminal side should lie in the appropriate quadrant. In step 2, you're going to form a right triangle by extending down or up from the terminal point to the x-axis. In step 3, you're going to label theta in the right triangle. Theta is the acute angle formed by the terminal side and the x-axis. In step 4, you're going to label the sides of this triangle according to the given trigonometric function. And in doing so, you need to be cognizant of signs, whether things are positive or negative. And then in step 5, you need to use the equation x squared plus y squared is equal to r squared, which is the Pythagorean theorem, to find the value of the missing variable. Okay, and then once you have that, all the sides of your triangle should be labeled. Okay, you're going to apply in step 6 the following definitions to find the values of the remaining trigonometric functions. Okay, so in the box, we have our right triangle definitions. Okay, that's in terms of the x value, the y value, and the r value, which is going to be the hypotenuse of the triangle that you've drawn. Okay, so let me write that down. R is the hypotenuse of the triangle. Okay, so you know, this is kind of it might be a little abstract for you, but just remember, you're using this box is saying you're using your right triangle definitions here. Remember that sine is the same thing as the opposite over the hypotenuse. Okay, the cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. And then cosecant is basically you flip the sign, so it's the hypotenuse over the opposite. The secant, you flip the cosine, so it's the hypotenuse over the adjacent. And then the cotangent, you flip the tangent, so it's the adjacent over the opposite. Okay, that's all this box is saying. Okay, so basically you end up drawing a triangle in the appropriate quadrant to reflect the given trigonometric property. Okay, you use Pythagorean theorem to find the remaining side, and then you apply your right triangle definitions. Okay, the last thing I want to review before we do a couple of examples is the signs of the trigonometric functions. Okay, so you have the four quadrants, okay, and then we have it broken down by sine and cosecant because those guys are going to have the same signs, positive or negative. Then we have the cosine and secant, those guys will have the same signs, and then tangent and cotangent. Okay, what you need to remember or recall is that everything is positive in the first quadrant. Okay, in the second quadrant, if you think about it, okay, so first quadrant, everything is positive. Okay, in the second quadrant, okay, you have negative x values and you have positive y values. Okay, so since the sine is the y value, okay, that means your sine is going to be positive, so your cosecant will also be positive. Okay, in the second quadrant, like I said, the x coordinate is negative. Okay, so that's associated with your cosine value. So your cosine and your secant will be negative in the second quadrant. Okay, remember tangent is sine over cosine, so that's going to be positive divided by negative. So tangent and cotangent will be negative in the second quadrant. Okay, moving on to the third quadrant. Okay, your x coordinates are negative, your y coordinates are negative. Okay, so since sine is associated with the y value, okay, sine is going to be negative, cosecant will also be negative. Okay, cosine is associated with the x value. Since it's negative in quadrant 3, okay, cosine and secant will be negative. Okay, again, tangent is sine divided by cosine, so it's going to be negative divided by negative. So you will have a positive tangent and a positive cotangent in quadrant 3. Last quadrant, quadrant 4, we have positive x values, negative y values. And so starting with sine, associated with our y values, we'll have a negative sine and a negative cosecant. Okay, cosine is associated with the x value. Okay, so that's positive. We will have positive cosine, positive secant in quadrant 4. Lastly, tangent is sine divided by cosine, so negative divided by positive will give you negative values for both tangent and cotangent in quadrant 4.